Hey there, today we're looking at how to factor expressions containing fractional exponents. Okay, so here's an example, x to the 3/2 plus x to the 1/2. How could you possibly factor this? Well, there must be a greatest common factor if you can factor this, right? And in fact, what we're going to try and do is take this smallest exponent, the x to the 1/2, and factor that out of both terms. So of course, factoring out of this term will just give us a 1. So that's sort of the goal. We want to make this into a 1. But what do we get if we factor it out of this term? Okay, so we can think of this x to the 3/2. We can think of this as the product of two terms, x to the 1/2 multiplied by x to the something, right? Because we have to add the exponents if you want to get 3/2. So what 1/2 plus what equals 3/2? Well, it's going to be 2/2, right? So 1/2 plus 2/2 equals 3/2. That's how we get this. And of course, this is the same as x to the 1/2 times x, right? Because 2 over 2 is just 1. So this is x to the first power, just like that. So I am now going to rewrite my original expression here as being x times x to the 1/2 power plus x to the 1/2 power, okay? That's what I've done. And now recognize that in both of these terms, we have an x to the 1/2 that we can factor out. And that's what we're going to do. So we're going to say we can factor out the x to the 1/2 and we'll be left with x plus 1, and we've done it, okay? So that is how we can factor out an expression with a fractional exponent. You essentially want to try and factor out this smallest exponent from all of the terms, okay? And that's the goal here. Let's take a look at another example. All right, so for this next one, we're going to do the same thing. We're going to try and factor this y to the 2/3 out of both terms. Of course, factoring out of this is easy, but how do we factor it out of a y to the 5/3? What we're saying is that y to the 5/3 must equal the product of y to the 2/3 times y to the something, okay? And what is this going to be? Well, whatever that is, if we add it with 2/3, we'll get 5/3. So this must be then 3/3, right? Because 2 plus 3 equals 5. Okay, so that's how we get that. So what I'm going to do now is I'm going to rewrite my original expression here as 6 times y to the 2/3 times y, okay, because 3 over 3, that's just 1. So that's y to the first power, minus 9y to the 2/3. There we go, okay? So I just want you to recognize that we have a common factor of y to the 2/3 now in both terms. That's the goal. That's what we were trying to achieve. So we can factor that out. So if we do that, we're going to get a y to the 2/3 multiplied by 6y minus 9. Okay, that's what we're going to get here. But we can also have a greatest common factor here from the 6 and the 9. It's going to be a 3, right? So technically, we could get a 3y to the 2/3 times a 2y minus 3. And now we have factored this completely. Okay, we can't go any further. Let's look at another example. All right, same procedure here. We've got this y to the 1/2. We're going to try and factor that out of both terms here. So we have a y to the 5/2. Let me write that a little bit better. That must equal y to the 1/2 times y to the something, right? And 1 plus 4 equals 5. So that's what this will be. I can simplify that to y to the 1/2 times y squared. All right, so let's rewrite our original expression now. We have 9 times y to the 1/2 minus 25 y to the 1/2 times y squared. And once again, we can recognize this common factor here of y to the 1/2 in both terms. So we're going to factor that out. We'll get a 9 minus 25 y squared, but we're not done yet because this we should be able to recognize is going to be the same as 3 squared minus 5y squared, right? That's what this equals. So this is the difference of two squares. And so we know the special formula to factor that one, right? So in the end, what we should get is a y to the 1/2 multiplied by a y plus, 3 plus 5y multiplied by a 3 minus 5y. And now this should be our final answer here. We factored this expression completely. Let's do another one. Okay, so here we could try and do the same thing. The problem is that this is the smallest exponent, but it doesn't exist in this third term, so we can't factor it out of here, okay? Instead, what we'll do is we'll do our kind of, u-substitution deal that we were doing before. So let's define u to be y to the 3/5 power, okay? So this is our first step. Now, if we do that, what we're going to see then is, well, this is just going to be a minus 7u, right? But what is this in terms of u? Well, we can think of this as some y to the 3/5 power, and you could either think of this as y to the 3/5 squared, or y to the 3/5 times y to the 3/5, because 3 plus 3 equals 6. And 3/5 squared, well, that distributes in, so this will become a 6/5, right? So you can replace it with either of these. And so notice now, if we rewrite our original equation, we're going to get a u squared minus a 7u plus a 10. Okay, so now we just have a normal quadratic expression that we can factor. We need to find the factors of 10 that add up to give us -7. What are our options? Well, our options, they must be negative, right? So -1, -10, -2 times -5, and that's it, right? So, of course, this one gives us -11, but this one does give us -7, so that's what we're looking for. So we should get a u minus 2 multiplied by a u minus 5, okay? And then we just have to substitute our u back in here, right? That's going to be a y to the 3/5. So this becomes now a y to the 3/5 minus 2 multiplied by a y to the 3/5 minus 5. And that should be it. That'll be our factored form. Let's do another example. Now for our final example here, the smallest exponent is going to be this t to the -1/3, okay? So it's a little bit strange. It's a negative power here, but we can deal with that. We want to try and factor that out of all three terms, okay? Factoring out of this last term will just give us a 1, so that one's easy. But let's look at these other two, okay? So if we're trying to look at our t to the 5/3, and we're trying to factor a t to the -1/3 out of that, well, what does that give us, right? Some product of something over 3. So again, so it's -1 plus something is going to equal 5. That must be a 6, right? So 6 minus 1 equals 5. And we can simplify this. This becomes a t to the -1/3 times t squared, right? This just becomes a 6/3 is just a 2, okay? So that's what we get for our first one. Next, we're going to have a t to the 2/3, and again, we want to factor out a t to the -1/3, and so that's going to be some number here plus -1 equals 2. Well, that's going to be a 3, isn't it, right? So 3 minus 1 equals 2, and simplifying that, we get t to the -1/3 times just t, right? This is just a 1 there, okay? So with all that done, we can rewrite our original expression now. We see t to the 5/3, that's going to be t to the -1/3 times t squared, minus 4t to the 2/3 becomes t to the -1/3 times t, and then finally we get a plus 3 t to the -1/3. Now again, notice we have now a common factor in each of these terms of t to the -1/3. So we're going to factor that out. T to the -1/3 times t squared minus 4t plus 3. That is a normal quadratic expression that we can factor. We need the factors of 3 that add up to -4. And so we get a -1 times a -3, and that's it, right? Because adding these does in fact give us -4. So that's going to be the numbers that we're going to use here. We'll have a t to the -1/3 times t minus 1 times t minus 3, and we're done. Okay, so that was the last example. Hopefully this shows you a few strategies you can use when factoring expressions that contain a fractional exponent, right? Essentially, the goal is to either use some kind of u-substitution where you can take that fractional exponent and replace it with like a u or some other variable, Or you can try and factor out the smallest exponent. If you have this exponent in each term, try and factor that out of each term, and hopefully you'll wind up with something that's a little bit easier to work with. Okay, so come back next time when we look at how to factor by grouping. We're going to be looking at cubic polynomials and how we can sometimes factor those by grouping in special conditions. Okay, I will see you there.